relationships of other angles formed by transversals. So we are going to expand upon what we did on Tuesday. Keep in mind, most stuff from Tuesday, that's still a thing. We're going to use all of that. In fact, we need to make sure we know all of that, because we're going to use it going forward. Important thing. So allow me to remind you of Tuesday. We started with the transversal. A transversal is any line that cuts two others. Pretty simple. And when a transversal cuts two lines, 8 angles are created. The first thing we talked about on Tuesday was that of those 8 angles, there are 4 at one intersection, there are 4 at another intersection. What we're trying to do is find just naming relationships between any of these 4 angles and any of these 4 angles. Pick one from up here, pick one from up here. What's the relationship? We did initially discuss that the basic way to name any angles from one intersection to the other would be to first name based on its location with respect to the transversal. Are the 2 angles on the same side or on alternate sides? And then name them based on their location of the 2 lines. Are they on the interior portion of those 2 lines, or are they outside the exterior portion of those 2 lines? And we talked about all of that and we expanded on it, but then we realized there were certain angle pairs that didn't follow that same nomenclature. Specifically, corresponding angles are 2 angles that open in the same direction, or they're on the same side of the transversal. One's inside, one's outside. So like over there, 1 and 5, both are top left of the intersection, both open that direction, as would 2 and 6, 4 and 8, and 3 and 7. Those are our corresponding angles. They didn't follow that naming thing. But corresponding angles were fairly useful. We figured out a couple things about them, specifically location. And then, when the transversal cut lines that were parallel, we discovered by doing a simple translation, by moving that angle along its transversal to its corresponding location, that, oh, hey, look, it's the same angle up there too. Which told us, oh, when a parallel line cuts, when a transversal cuts parallel lines, corresponding angles are congruent. Da, na, 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 na. Dancing in a chair is very hard. I make up my own words to songs. Stop laughing. Anyway, I know you're not laughing. You're just shaking your head. I have to deal with this for an entire year. Yes, you do. But you know, after today, 1 month is done. Did you know after today, 1 month? It's been 4 weeks. My goodness, it's felt like 4 years. It's awesome. So yes, corresponding angles are congruent. I'm sorry. I do love my job. It's a lot of fun. But this chair is like, I'm a mover. I need to be walking. Sitting in a chair is not. Anyway. So yes, we realize that when a transversal gets parallel lines, corresponding angles are congruent. That is correct. That was the main takeaway from Tuesday. Huzzah! Woo! But what about all those other angles that we had mentioned? You know, obviously we talked about the transversal and corresponding angles, but remember that naming stuff? Same side, alternate, interior, exterior. What about those? We have other angles we were talking about. What relationships do those have? Alternate, interior angles, like, 4 and 5, or 3 and 6. They're on different sides of the transversal, alternate. And they're both within the 2 lines, alternate interior angles. 1 and 8, 2 and 7, those are alternate exterior angles, alternate sides of the transversal, outside of my 2 lines. Part of me always wonders what one would look like if the volume was off. I'm just doing all these signs. Never mind. And what about same side interior angles? Same side. Within the 2 lines. 4 and 6. 3 and 5. Same side interior angles. What about those relationships? Are they the same as corresponding angles? Are they totally different? Well, I don't know. So let's figure that out. And as we figure that out, I want to remind you of something. What we are going to do is combine everything we know from Tuesday from the last Friday, which means we are going to combine what we know about corresponding angles, which means that obviously when a transversal cuts parallel lines, corresponding angles are congruent. So we're combining that with what we know about vertical angles and linear pairs. We're going to combine all of those. So really basic stuff. But we're going to combine all of that to develop relationships for those three guys. And actually, we're not limited to those three. Alternate interior, alternate exterior, same side interior. What about same side exterior? Are those a thing? Yes, they're a thing. What about things that don't have a name, like 1 and 6? What do we do with them? I'll tell you. But let's knock out these three really quickly. And then I'll explain and make this really cut and dry for you. So it's even super simple. So, let's talk about alternate exterior angles. Let's start with what we know. We know corresponding angles are congruent when a transversal cuts parallel lines. We know that. So corresponding angles. These are corresponding. Okay, we got that. So we know they're congruent. However, we're not trying to find a relationship between corresponding angles. We already know that they are congruent when a transversal cuts parallel lines. We are trying to find a relationship between alternate interior angles. So I would want a relationship between this one and this one. These angles are on alternate sides of the transversal and within the two lines. So those are the two we want to find a relationship between. These two. Well, in order to do that, here's what we're going to do. And by the way, I would strongly suggest you pay attention to this. Classwork. Kind of a thing. Here's what I'm going to remind you. Hey, these angles are corresponding. And corresponding angles are congruent. That's very nice. I would also mention that, hey, this angle and this angle are congruent because they are vertical angles. Remember, directly across an intersection from one another. These angles are congruent. That's very nice. So that means not only are my corresponding angles congruent, but so are my vertical angles. So all three of these angles are congruent. Well, if all three of them are congruent, two of those angles are my alternate interior. So it looks like my alternate interior angles are congruent. So guess what? When a transversal cuts parallel lines, alternate interior angles are congruent. Wow. That's pretty simple. Huh. Okay. What about alternate exterior? Well, let's continue. First of all, alternate exterior, different sides of the transversal outside of the two lines. So you know, like these two, this one, and this one are alternate exterior, different sides of the transversal outside of my two lines. Okay. Well, hey, I will remind you, corresponding angles. These are congruent. We know that already. That's pretty easy. We've done it a few times. And hey, guess what? This angle right here and this angle right here are vertical. So they must also be congruent. Well, that's pretty simple. So if this angle and its corresponding angle are congruent, and then this angle and its vertical angle are congruent, then all three of those angles are congruent. Well, if all three of them are congruent, two of them are my alternate interior angles. Or sorry, exterior. Hey, my alternate exterior angles are congruent. So wait a minute. So when a transversal cuts parallel lines, alternate exterior angles are congruent. Well, that's nice. I'm noticing a pattern. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. This is great. Well, them. Same side interior. Well, I don't know. Let's investigate. Same side interior angles, same side of the transversal within the two lines. Interior. You know, I'm not a smart man, but I'm looking at these angles, and I'm just telling they're probably not the same. This is clearly acute. This is clearly obtuse. There's no way, right? Right? Well, let's keep using the stuff we know. So let's start with the corresponding angle pair. We're really good at that. Okay, corresponding. Let me do this one. This one. And this one. Corresponding angles right there. We know they're congruent. So we've got that down. But we weren't trying to make a relationship between this angle and its corresponding one. We want this one with its same side interior one. Well, now let me remind you that the angle, which was the corresponding one to my initial one, makes a linear pair, forms a line of two angles, with this angle it is adjacent to. So these two angles must add to 180. Well, if this angle and its adjacent angle add to 180, and this angle and this angle are the same because they are corresponding, well then this angle and this angle, its same side interior one, would also have to add to 180 because it's like the exact same angle that it forms a linear pair with. So it appears as though they're not the same. We can kind of see that through inspection, just looking at it. But they do have a relationship. They're supplementary. They add to 180 degrees because you're taking this angle and basically moving it in here. So you make it kind of like a linear pair. So we have one bit of divergence. When parallel lines are cut by a transversal, same side interior angles, they're not congruent. They're supplementary. They add to 180 degrees. So here's where Ariano just comes at you and says, look, I'm just be straightforward with y'all. When a transversal is cutting parallel lines, there's only going to be two possible angle relationships. Because keep in mind, we didn't talk about same side exterior, and we didn't talk about just like any random pair like 2 and 5. So you know what? Let's make this really easy. And for those of you that weren't paying attention, first of all, sucks for you because the classwork I pretty much just did for you. But I'm going to make it cut and dry for y'all. I got a nice little line in my hair right there. That's really weird. I'm like, I don't know, like some 90s rapper with some random line in my hair. I don't know. Anyway, yes, there are two possible relationships that any two angle pairs can have when a transversal cuts parallel lines. There's just two. One, those angles are congruent. And two, they're supplementary. That's it. That's all the angle pairs could be. No matter what, you take one, you take another, they're either going to be the exact same measure or they're going to add to 180. That's it. You don't have to worry about anything else. And I'll tell you what's more. Well, it's going to be very beneficial to remember that, yes, corresponding angles are congruent. Alternate exterior angles are congruent. Alternate interior angles are congruent. I know I did that backwards, my bad. Same side interior angles add to 180. As long as it's very good to know all of that. It will be helpful to know all of that. But if you're ever given a diagram, I'm just going to be honest with you. Use your brain. Wait, what? Brain? Yeah, brain. Use your brain. Why? Well, your brain's actually pretty good. Y'all pretty smart. Hey, this angle right there and this angle right there. Wow, you know, they kind of look the same. They sure look like, I mean, they're both acute. They're both clearly less than 90. And so is this one. They kind of look the same. Well, you know what? If they look the same, they're the same. If they look like they are the same, they are the same. They have the same measure. They are congruent. Don't make it more complicated. You can clearly see there are a series of acute angles and a series of obtuse angles. Clearly. All of the acute angles have the same measure. All of the obtuse angles have the same measure. Boom, done. And guess what? What about that random pair that we talked about? Hey, this one and this one. They have no name or any sort of relationship. I don't know. But you know they don't look like they're the same. This one is clearly obtuse. This one is clearly acute. They don't look the same. They're not the same. So if they're not the same, guess what? They add to 180. Hey, let's talk about same-side exterior angles because we didn't have an explicit definition for them. That one and this one. Same-side exterior. One's obviously obtuse. One's obviously acute. I'm guessing same-side exterior angles are supplementary? Yup. That's it. Don't overcomplicate this. In the grand scheme of things, if you have diagrams especially, just use it to know that angles are congruent or angles are supplementary, and that's it. Those are all the angle pair relationships that we have. Yes, again, I'm going to remind you, it is good to know corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, same side interior angles are supplementary. It's good to know. Because I could theoretically not give you a diagram and just say, hey, you have two pairs of alternate interior angles and their measures are this and this. But most times you're going to have a diagram. So like this. Most times you're going to have a diagram. Find the measure of EDG. EDG. Yes, I mean as a whole, you should note that, okay, I want to find the measure of this angle. Does it have any sort of relationship to this angle? Because the reason I'm choosing this angle is because it's known. It's 75 degrees. And yes, I should know that those are alternate exterior angles. And alternate exterior angles are congruent when my transversal cuts parallel lines, and they are parallel. So I should be able to go, yeah, alternate exterior angles, that tells me they're the same. They are congruent. That's good. I should know that. Okay, good. But, I mean, it is totally within your right to go, okay, there's an acute angle. Hey, this acute angle is 75, so they're just the same. If you do not remember that alternate exterior angles are congruent, and you have to do that, okay. That's fine. But you have something to fall back on. Again, I encourage you to learn the angle pair relationships. But if you don't, you have an easy way to figure them out. Measure of angle BDG. That's this one. Normally, here's what the book would have you do. Okay, I want to find the measure of that angle right there, where the X is. Okay, well here's what I'm going to do. I already used alternate exterior angles to tell me that this angle and this angle were congruent at 75 degrees. And then, these two angles make a linear pair. So the angle I'm trying to find will be 180 minus 75. So I'm going to use alternate exterior angles to get here. And then I'm going to subtract from 180 because they make a linear pair. Oopsie, go back. There we go. That's what the book would have you do. And that's totally fine and totally legit. And I would suggest doing that. But just so you know, okay, I know this angle is 75 and it's acute. This angle is obtuse. So they aren't the same, so they add to 180. So subtract 75 from 180, which is, by the way, oh, sorry, not that. Yeah, what I did, yes. That's it. Don't overcomplicate it. Now, sure, I can do something like I did on the quiz. And instead of just giving you numbers, I can give you expressions. And sure, you might have to go, all right, and by the way, this isn't very clear, so let me tell you. This angle and this angle. Okay, they're both alternate exterior angles. Yes, you should know that they are congruent. But if you don't, you can still recognize that, okay, this is an acute angle. And this is an acute angle, so clearly they must have the same measure. Well, if they have the same measure, then the angle measures, which are represented by expressions 2x plus 10 and 3x minus 15, you do need to recognize, okay, they're the same. They're the same. So I set them equal to each other? Yeah, because, alternate interior angles are congruent. Or you can just look at them and go, okay, they're both acute. so they're the same. Fair word of warning, because again, and I've done this plenty of times, but still it happens inevitably. Just saying, you would solve for x here, like most of you would do, and that's fine. And most of you are going to select it as your answer, but that's not going to be correct. And by the way, come quiz or test, and by the way, this did happen on Wednesday, like I would have that as one of your possible selections. Ooh, 25, I got 25. Answer. Next question. I didn't ask you for x, people. I asked you to find the measure of ABD. A few people have been going through classwork and homework kind of quickly, and that's fine. There's nothing wrong with that. I understand you're just trying to be efficient and knock stuff out. That's cool. But please just know that especially quiz and test time, please make sure you're answering the question that's asked of you. For this question, I asked you to find the measure of ABD. Find the measure of this whole angle. I didn't say solve for x. If you're finding the measure of ABD, you need to plug into this expression. So plug 25 into that expression. That's what I do. So I take 25, I plug it into 2x plus 10, and I solve for my measure. I don't want this to be tricky. But if you are being careless, or just trying to fly through things, that's an easy mistake to get tripped up on, and I don't want you to. All right, pausing for questions, because we're almost done. No questions. I'm hopeful because I'm doing such a great job of this. We'll see. All right. Okay. I can make this moderately more tricky. I am not going to make it that tricky. That's not fair. At least, well, probably not fair. But let me just demonstrate something to you. Eventually, you're going to have more complex diagrams. It's not always as simple as, hey, a transversal cutting two lines. That's easy. Oh, I added a few more lines. Whatever do I do? The goal of all of this is always just to find, remember, and I did talk about this on Tuesday, your goal is to find relationships between two angles, and those two angles have to be touching the same line, and that same line will be your transversal. They only form angle relationships if the two lines that are crossing are parallel. So I would always look for parallelism if I were you, and a non-parallel line cutting them. So here's what I'm saying. In theory, I could try and find a relationship between this angle right here and this angle right here that are represented by the two expressions. And yes, they're corresponding angles. They are in corresponding locations. If I isolate just that portion, if n is my transversal, these two angles are indeed in the bottom left-hand portion. So they are corresponding angles. They are in corresponding locations. Their name doesn't change at all, ever. However, as you can probably, well, maybe you can or can't tell, I don't know. But like, it kind of appears that their angle measures are not the same. And the fact is they're not. They are not because the two lines that they cross, or that are crossed by that transversal, are not parallel. You can see they're kind of skewing together. When they're not parallel, we can't make a relationship between the two. It doesn't help us. So instead, we should try and search for other angle relationships along another line. So like, for example, this one and this one. Hey, those are corresponding angles. They're bottom left. If your transversal is P, or that's a Q, isn't it? It's a Q, sorry. If my transversal is Q, those are corresponding angles. Bottom left. And guess what? The two lines that are crossed are parallel. I could then make a relationship between those two. This angle, the 5x plus 5y, and this 60 would have to be congruent. They're corresponding angles. The lines that are crossed are parallel. They have the same measure. Cool deal. What can sometimes get difficult is recognizing this 5x plus 4y and this 55. Now, they're obviously on different sides of line P. This is my transversal. The two angles are touching parallel lines, I might add. So my P is crossing parallel lines. But it is also crossing, you got a third one in here. What do we do then? How do we make a relationship between these two angles if there's a line in between them? The short answer is you don't worry about it. You act like it's not even there. And if you act like it's not even there, then this angle is on a different side of this one, and they're within two parallel lines. Those are alternate interior angles. So if they're alternate interior angles, they're congruent. Now, I'll be honest with you. Again, I wouldn't ask you to solve for either of those two variables. You can, because what I would expect of you is to establish two different equations, knowing that the alternate interior angles are congruent, so that the 5x plus 4y is equal to 55. And knowing that the other set of corresponding angles are congruent, the 5x plus 5y is equal to 60. Those are things I would expect you to set up. And yes, could you go further from there? You could. I'm not going to make you do it, though. I would expect you to be able to set these up. These expressions right here, to know that, okay, these are alternate interior angles, so they're equal. These are corresponding angles. Their measures are equal. That is what I expect of you. No, I could make you go further, but I won't. So, in summation, here's the basics. Yes, I do expect you to know that corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and same side interior angles are supplementary. Yes, I do expect that. Truth be told, you can look at diagrams and tell most of the time, especially if it's just two lines cut by one other. You could do that. Please just be alert. That's it. Oh, but one thing. We're eventually getting to more slightly complex stuff. Now, before everyone gets all crazy on me, take a deep breath, and let me assure you that right now, we can't solve everything right now. But there are some things you can solve. Here, let me show you. Anybody know what the measure of angle 1 is? George, why is it 90? You beat Venus barely. It is 90, you're correct. Why is it 90? Very good, George. Excellent. Angle 1 right here is in a corresponding location to this 90-degree angle. They're both top right. Corresponding angles. Good. By the way, Venus, I saw you. I'm giving you a point to you. Correct. Exactly. All right. Anyone but George and Venus. Anybody know the measure of angle 6? I see a 118, and 118 is correct. Very good, Austin. (118), this angle, and angle 6 are in corresponding locations. If you ignore this line right here, here's my transversal. I'm going to do this very hastily, I apologize. Here's one set of parallel lines. Here's the other line that's parallel to. These are corresponding angles. They're congruent. Exactly. Okay. Let's see. Venus, Austin, and George. Anyone but them. How about the measure of angle 2? Good. Amelie, Alyssa, Mason, Jaden, rockin'. Very good. It is also 118. Correct, because I have 118. And this right here, if this is my transversal, and here are my, oh no, no, now I need to wait for it to do it again. Here's my transversal. One set of parallel lines, another set of parallel lines. A terrible job of drawing 118. And 2, those are alternate exterior angles. They're congruent. Yep. Here, let's see if here, moderate tough one. Not really. Measure of angle 5. Wow, we are on this. 28, very good. Mason. 28 is correct. Very good. 5. And my 28-degree angle, if this is my transversal. And here are my 2 lines that are cut. Those are alternate interior angles. They're congruent. And you know what? There's a lot of other things you could figure out. I'm not going to make it any more complicated because there's plenty of things you can do. But I'm going to stop there.